Hey there, Internet. Well, because I'm a glutton for punishment, I decided to queue up another project, the almost infinite queue of projects that I'll probably never get finished. But this is a Wade number 7 lathe spindle. And I just want to do a quick teardown to show you kind of what's inside of this thing. It's kind of interesting. It's got a really interesting bearing arrangement, and I'll just kind of walk through some of the issues that I found with this. So the first thing I'll show you is that the table hold down mechanism, or the hold down mechanism to the bed, is essentially an eccentric here, and that eccentric rides on this, and then this pulls this up into the body of the spindle head, and that's what locks it down to the actual lathe bed. And there's two of these, and I don't know if you can see this, but this one has cracks all the way around, and this is hardened. So a couple things I guess has happened. People just crank the hell out of it, and it's very mushroomed. You might be able to pick that up on the camera, but this end has been splayed out considerably. And what that does is, because this is, you know, kind of a precision fit, the other one of these, this one, oops, when I got this thing originally, this one had a Allen key that was broke off flush with the face of this, and this one's less mushroomed on the end, but it was completely jammed in there flush with the face. So I really had a battle to get this out. I ended up creating a tapered pin, and I bored a hole with a carbide end mill into the Allen wrench. And then I drove in the tapered pin, and then I pulled on the tapered pin to pull this out, to disengage this from the slot. So that was the first big battle with this particular thing. Now this has a collet closer on it, but it didn't come with a drawbar. And so I made this drawbar. This is 1 3/8 Dom tube with a threading for 5C collet. The spindle nose is set up for what's called a Wade collet, which is almost exactly the same as a 5C collet. The taper angle on the head of the collet is the same, 10 degrees, but the thread is different. So anyway, that was one of the reasons I bought this, is because the fact that I can use 5C collets, I just had to make my own drawbar, and I got this thing for $150 shipped, which is, I think, pretty amazing considering how good it turned out to, actually the condition it turned out to be. So I don't really understand how this collet closer mechanism is really supposed to work. There's dogs here, and this back piece seems to move a little bit, but I think for my purposes, because I'm not going to be, I doubt I'm going to be doing any kind of production work on this thing. I'm just going to remove this whole thing from the end, because I don't need a collet closer. If for whatever reason that I need to actually have this on here, I can always put it back. So I'll just pull this off real quick. This bearing is also highly questionable. It doesn't sound terrible, but it's really sloppy and really old. So anyway, this is probably going in the bin. I've already had the thing stripped down, so everything's not tight necessarily. But there are 2 set screws on this ring, and then once you loosen those set screws, this ring pops off, and then you should be careful when you pull it off the back, because inside of here there are a couple little brass, they're actually threaded, they have the thread imprint in them, and those brass pieces interface with the set screw and the thread, so that you don't damage the thread. So just be careful you don't lose those when you pop this off the back. Okay, so then the next thing I'll just go to before I take the spindle out, this, on the back of this we've got index holes I don't know exactly how many of them. It looks like about 60. And this pin here is just completely worn out. So I'll have to fix that. There's a flat in here, and then there's this little set screw so that you can set that in there. It actually does, it does go into the hole, but I'm sure you can see there that there's almost nothing left on the end of that thing. So I'll have to make it either turn this down to the hole size. I don't think I'm going to make another one. This one's going to be fine. Now up here, this piece was stuck in there, and you can see there's a hole on this side, and I had to grind this off. This was broken off just a bit proud. I had to grind it to get it to come out of the hole. So there's a little handle here that goes into that hole, and that interfaces with these larger holes, and we'll get to them in a second because I got a lot of work to do with them. So that's how the indexing and the spindle lock works. Down here, there's these oiler holes, but this was set up with grease. And I don't know if these oiler holes will actually work because I have oil in there right now. I wanted to flush some oil through there, and it leaks like a sieve. Okay, so the next thing, if you want to pull this thing apart, the next thing you have to do is you have to get this ring off. Now, this ring has caused me a bunch of problems, and I'll show you my kind of hacky solution to that. The way that this ring is, this isn't really required because when they cut this slot in here to allow the ring to open and close, there must have been stress on the material and the ring shut in. So there's a lot of clamping force in there just the way it is. Actually, I'm going to use this to help me hold it in place a little bit. So I'm just going to spread this apart a little bit, and I've got this little piece of aluminum here, and I'm going to stick it in the slot just to kind of hold it open, because again, it really wants to clamp down on that thread. So once you get this thing off, you're pretty much into the spindle. Now, I also milled a bit of a notch in here. This was kind of all boogered up all the way up to the top. So I put this in the mill and put a little slot in here. And the reason I did that is so I can put a spanner wrench on there and crank it without necessarily having the, I couldn't, there's no way I could fit it into this little tiny space here. It's just a couple millimeters. So this ring here creates the preload. So you tighten this nut, it pushes against this, and it pulls the nose of the spindle into the bearing arrangement in the front of the spindle. So this is just a spacer to create the preload. Okay, so then you just pop this plate off, and you have access to the rear bearing here. Which again, when this was set up with grease when I got it, and there was like an unbelievable amount of 70-year-old grease in there. So I don't know if I got it fully clean. I put some kind of crappy oil in here just to get it flushed out. It sounds pretty good right now, but it may require a little additional cleaning. All right, so you can see this front piece is loose. There's a brass shim in here that creates a bit of a labyrinth seal. But we have to loosen the set screw first. Okay, so now that this pulley is loose, that's the only set screw. There's a key that runs perpendicular but incidental to the set screw. The set screw pushes down on the keyway. You can see the keyway here. So once we have that off, we should be able to beat it out of here. Here's my collet. Just going to set this aside for now. Okay, so here's the rear bearing. It's just a regular deep groove ball bearing. There's felt or leather seals in these two rings, and I haven't pulled these out. I'm going to just leave those in place. I think they're press fit in there. And then on the inside of here, we've got the interface for this precision thrust bearing that sits in the rear here. And then down here we've got the interface for these double row roller bearings, which when I had this thing mocked up before I just took it apart again, there doesn't seem to be any play with a pretty light amount of preload, and I'm very optimistic that this spindle is going to be actually pretty awesome. These roller bearings look like they're in perfect shape. These thrust bearings also look perfect. I don't see any issues. The surfaces have no scratches or anything in there. I think if I'm able to get this clean and repack it with grease, this spindle may have a lot of life left in it. So I'm pretty excited about that. So that is the spindle. These two pieces come off again. There's a shim here that rides in a slot that interfaces with these two plates and creates the labyrinth seal in the front of the lathe. So the reason that I took this back apart, the main reason I took this back apart, is that this pin that interfaces with these locking holes, because this is when you put the I don't actually know. I'm just assuming they were rough with the lathe and beaten on it, and when they were locking the spindle, this just got a lot of use, this locking pin. So all these holes are wallered out, and I believe this is hardened because there's not really any wear on this pin. So what I'm going to do is I'm going to put this in the rotary table and re-drill and ream the locking pin holes, so that this is now a good fit again, and this oblongation from just years of use doesn't become a factor. So that was a big reason that I needed to get this particular part out of here. I'm thinking about doing a bunch of crazy stuff with this thing. I'm thinking about CNC, making a little tiny CNC mill with this as the head. I'm not 100% certain on my plans here, but one of the ideas that I had was maybe I don't keep this. Maybe I can make another pulley sheave and either use serpentine belts or poly V belts, some other kind of belt, and then put this on a motor with a VFD to give me the speed control that I'm gonna want to have. So I haven't really decided on that. I may just proceed and restore this and then decide after I do that. I can always pop this thing back apart and put something else in here. I do want to do one thing. I just want to see if there's any taper on this. This is the only thing short enough I have to get in there. Yeah, that's dead square. So, yeah, there's no taper on this. So 100% of the yeah, I don't know how this works actually. I don't know how you take up any lateral move with a roller bearing like this. I mean, it's not exactly like a super tight fit. So yeah, that's pretty interesting that this is square. There's no taper at all. I mean, this does provide some alignment with preload, so maybe this is doing a bunch of the work to keep it in place. It's a weird idea. So there it is. If you have any questions, I mean, I'm sure there's like 4 or 5 people on the internet that have one of these. Hopefully this was helpful to somebody. If you have any questions or you have one of these and you have some comments, leave it down below. And thanks for watching.